So today we'll look at the topic called damping. So, damping by definition it goes like this: a reduction in the amplitude of an oscillation as a result of energy being dissipated as the other forces, some resistive force act on it. So to know that properly, we must have a look at the difference. So what was SHM? Simple harmonic motion. So what happened was, in there the energy was always conserved. The energy was conserved, and moreover there was no resistive force, or we can say we didn't consider the resistive force. And the other thing was, it was a repetitive motion, which was, so hence we called it periodical, and hence we got a graph which was something similar to this. It was periodical and it repeated, and we also named it simple for that, and we talked about why it's simple. But what happens in reality is that the energy from the system is lost. So what if energy was lost from the system? I mean, we consider there is a loss in the system. And how is the energy lost? By resistive force. So for instance, if you are like in real life scenario, if you're swinging and if you push once, what happens is, and you leave it like that, it's not going to come back to the same point, as there is a air resistance each time working in opposite direction. So this is the action force and this is the opposing force. So each time you are not getting back, and the motion is not repetitive, and it's not, I mean, periodical. So we find there is a loss in energy. And so how do we represent that? I mean, and also we get a graph of the energy getting less each time is like this. The amplitude decreases and all the other things remain the same. So the amplitude is decreasing. The amplitude decreases because the energy is decreasing, and we can also, I mean, in a way call this critical oscillation, but we name this process damping. So if you look at the definition again, like we said, it's a reduction in the amplitude of an oscillation as a result of energy being dissipated. So we can, I mean, match the meaning with the explanation. Moreover, you can also ask a question. This question could come to your mind, that why is amplitude related with energy or something like that. So I'm just going to give you a real life analogy or something. Like if you're speaking loud, what are you doing? Like, you're stressing on your vocal cords, so you are using more energy. So we know from all levels that the for that graph, the amplitude is higher, and if you reduce the sound or the loudness, so you use less energy, you speak softly, and you get the same graph, but the amplitude is low. So that's why we can use the energy the amplitude to represent the energy loss or gain. And also we can say, like, I use this definition for remembering, is that we can also say it like this, that is the process of reducing transfer of forces using time dilation. So you will get to know this when we learn types of damping, but this is the definition you need to use in your book and in your questions. So in the next class we will look at the types of damping, and today we will leave it up to this.